That would make it a lot more expensive.
Fourier analysis. And what Fourier, as a mathematician, actually came up with, says any periodic function, I don't care what the shape of it, you can write that as a combinations of sine and cosine. So for example, if I take a square wave, when you go in the lab there, do we have a ruler here? Here is a square wave. When you're in the lab there and you make, you switch your scope to a square wave.
EE Pro does Fourier something.
So we'll go like this with this.
But I don't understand.
I don't understand anything at all.
What is the sign? 0.
Try to make it look a little bit clean there. We have a periodic function that repeats itself. It's a square wave. That's the closest you're getting to a square out of me. There we go. That's not bad. And let's say the height is 3 here. And let's say this is pi, and this is 2 pi, and that's 3 pi, 4 pi, and so forth. Negative pi. So you can see the function repeats itself. This is actually supposed to be covered in differential equation, Fourier analysis. That's a topic in differential equation. But you guys didn't cover it, so with Fourier said we can take this and write this as a combination. As you can take f of t and write that as some constant, we'll call it a0, plus a combination of sine and cosine. Any periodic function can be written as a constant plus a combination of sine cosine. Now, and I'll come back, it will be like a1 cosine of t plus b1 sine of t plus a2 cosine of 2t plus b2 the sine of 2t, I'll write one more term, plus a3 cosine of 3t plus b3 sine of 3t and so forth. And it repeats. a4, a5, a6, all the way to infinity. You can take any periodic function and write it like this. Now, the question is you have to find what a0, a1, a2, and b1, all these values. Now, our book actually breaks it down a little bit differently. This, instead of writing a1, a2, a3, a4, we're saying f of t can be written as a0 plus the summation, instead of writing 1, 2, 3, 4, from n equals 1 to infinity, of a sub n cosine n w0 t, depends what w0 is, we'll give you that, plus bn sine n w0 t. So a1 cosine w0t plus b1 sine w0t, then n becomes 2. a2 cosine twice that, b2 cosine twice that, then a3 cosine 3 times that, b3 sine 3 times that, and so forth. And the question is, how do you find a0, an, and bn? First, w0. If you want to figure out what w0 in this example, well, we need to figure out what our actually frequency is, or the period. If you look at the period for this example, the period is from here to there, which is what? The example I'm doing, what's my period here? 2 pi, right? And if you want the units for that, that means what? That's the time, seconds per cycle. It takes 6.28 seconds to complete one full cycle based on my picture I drew there. My frequency, if I want to find the frequency, is 1 over the period, which is 1 over 2 pi. And that's cycles per second. How many cycles every second does the function do here? Now, W0 is equal to 2 pi f. So in this case, that would be what? What's my W0 in this example? 2 pi. What's my frequency? 1 over 2 pi. So W0 is actually equal to 1 in this example. So when you go back to these expression, if you want to, for this one, you can rewrite that problem as what? A sub f of t equals a sub 0 plus the summation of n equals 1 to infinity of an cosine nt plus what? Bn sine nt, because W0 is 1. Everyone agree with that? Make sense? The question now, how do you find A0? What is A0? What is AN? How do you find AN? What is BN? Once I find these, then I can write the expression for it. Well, to find A0, if you look at our book, is definition for that, it's 1 over t, that's over a full period. The integral from 0 to t over a full period of f of t dt. That's how you find A0. That's the definition from math. You just got accepted. Fourier came out with that years ago. How do you find AN? AN, the definition for that is 2 over t, the integral from 0 to t over a full period of f of t cosine n W0 t dt. And how do you find Bn? It's 2 over t, the integral from 0 to t of f of t sine n W0 t dt. If I can find these three pieces, I just found an equivalent to this function in terms of sine, cosine, the combinations.
How did you know that was 2 pi for the period?
This is?
No, before this.
Oh, 2 pi?
How did you know the period was 2 pi?
Notice this, the function starts here,
Yeah.
and it repeats itself right here. That's one full shape, right? Then another one exactly like it, another one exactly like it. So from here to there, that's your period. It wouldn't start repeating itself, just like the sine cosine function. It repeats every 2 pi, right?
Yeah.
After in math, after 2 pi, it repeats itself. You start getting another exact function. And every 2 pi here, the function repeats itself. Right there, start to repeat. Next one. So here we'll repeat again. So you can see every 2 pi, you have exactly the same thing. And if you go back to the left, it's the same thing. So that's how I knew the period is 2 pi. So let's go back to this one. Let's find what A0 is. So this is all pure math now. Hopefully our math skills are good. Let's look at the definition of A0. Let me write it down again. A0 equals 1 over t, that's the period, the integral over a full period of f of t dt. There's your function. Well, my period is 2 pi. 1 over 2 pi. The integral, I'm not going to go from 0 to 2 pi because I know it should be from 0 to 2 pi, but I have two different values, right? I'll do this from 0 to 2 pi of f of t dt. Well, here's 0 to 2 pi. So I'm not going to go from 0 to 2 pi because it has a value of 0 from pi to 2 pi. So if you want to break it down, you go 1 over 2 pi from 0 to pi. And what's the value of the function? 3 dt, right? Plus from pi to 2 pi, what was the value of the function from pi to 2 pi? 0 dt. Remember that? Integration. So do the math. That piece goes to 0. Don't waste your time on it. Integrate the 3, that's 3t. Three over, oh, the value? You gave me the answer already? I don't know, I gotta see what the answer is. So now I gotta plug in the upper limit, which is what? So 1 over 2 pi. That'll be 3 pi minus 0. Yes, you end up with 3 over 2, which is 1.5, right? That's A0. Now let's find AN. I need A0, AN, and BN for all of these problems. What's AN? Again, I'm going back to the definition by Fourier. It says to find AN, it's 2 over t, the integral over a full period, f of t, cosine, remember W0 is 1 here, right? For this example, so that will be cosine nt dt. Again, I look at my function and I can break it down to two actually pieces. I can go 2 over 2 pi, the period is 2 pi, from 0 to pi, 3 times cosine nt dt, plus from pi to 2 pi, and what's the value of the function there? 0 cosine nt dt. You agree with me so far? Am I going too fast? I know it's early. I know you have a test coming up next too. Your brain probably there. So this one goes to 0. 0 times anything is 0. I can take the 3 outside, and that becomes what? 3 over pi. The 2's will cancel each other out. The integral from 0 to pi, cosine nt dt. What is the integral of cosine nt?
-1 over outside.
Yep. So positive.
Yeah.
Positive, yep. So that's equal to 3 over pi. This will be sine of nt. Actually, I don't even have to integrate it. Why?
I'm doing 3 over pi.
That's what's out in front.
The 2's cancel, I pull the 3 in the front.
Oh, okay.
Do you agree that the integral of cosine, remember, because what's the derivative of sine nt? Is it n sine nt? So basically, if you multiply this by n and you divide it by n, you end up not changing the problem. So if you put that this is really the sine of nt, and that n goes in the front. So my answer here from 0 to pi, I'm just showing you can do it that way. I just didn't do it that way. I'm assuming everyone's good in math, calculus. So you end up with what? an equals 3 over n pi sine of nt from 0 to pi. Now, let's do the math.
It's gonna be 0.
Yep. Sine t is pi here. N pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. What is the sine equal to? 0. Minus, when t is 0, what sine of 0? 0. Guess what? an is equal to 0.
So there's no cosine portion?
No cosine for that one. It's not always the case, but in this example, no cosine. Now, let's find Bn. And to find Bn, let me take the sheet out. Definition says Bn equal to, where's my definition? 2 over t, the integral from 0 to t, f of t, sine n w0t dt. I'll put that here. Now, t is 2 pi. The integral from 0 to 2 pi. Well, I gotta break it down, right? Let's just break it down. Why keep dragging it? 0 to pi, and the function has a value of 3 sine nt dt plus from pi to where? To 2 pi 0 sine nt dt. Again, this one is 0. The 2's cancel each other out here, Chris. You asked earlier what happened to 2's. So you end up with 3 over pi. The integral from 0 to pi sine nt dt. Where's derivative sine? Negative cosine, right? That'll be negative 3 over n pi cosine nt dt. Oh, there's no dt.
Yeah, it's just like,
There's no, I already integrate. No dt. And it's going from where to where? From 0 to pi. Again, remember, if you don't like what I'm doing here, go. If that was cosine nt, what's the difference with cosine nt? Negative n. So if you put negative n here, you put a minus to make sure you don't change it, you put an n here. So that's why you have negative 3 over n pi. Now you plug in the limits. This is Bn. Negative 3 over n pi. And when t is pi, that'll be cosine n pi minus, when t is 0, what's cosine of 0? 1. What is cosine n pi?
1 or negative 1?
Yes. It's either plus 1 or minus 1. When this is 1, the cosine is negative 1. When this is 2, the cosine is what? 1. So this guy will have a value of 1 if n is even. Will have a value of what? Negative 1 if n is what? Odd. So if you want to write Bn here, you go Bn, let's write it down, break it down. When n even, n is odd here. When n is even, the value of this is going to be 1. What's 1 minus 1? 0, it's gone. When n is odd, the value of this is what? Negative 1 minus another one, negative 2. What's negative 2 times negative 3? Negative or positive 6 over what? N pi. What does that mean? That means now this function here that you see right here, I can write that as, it's a0. What was a0? 3 over 2?
Yeah, 3 over 2.
Plus an. What was an? 0. Gone. Bn. Only the odd ones. The even ones will be 0. So only the odd ones. So you can't have any even value. What's odd? Like 1? If it's 1, let's look at this. When n is 1, what's the value? 6 over what? N is 1. 1 times pi? Pi times the sine of 1t. Then n becomes 3 because you can't use the even. When it's 3, that becomes what? 6 over 3 pi sine of nt, 3t. Then n becomes 5. 6 over 5 pi sine of 5t plus n becomes 7. 6 over 7 pi sine 7t, and continues all the way to infinity.
How can we write that as a series?
Well, you can write that.
Actually, we can give the impression and then just write all the odd numbers or something.
3 over 2, right?
Yep.
Plus the summation n equals 1 to infinity, odd, just say the odd ones, of 6 over n pi sine nt. So if odd ones only, so it's 1, 1, you get that one. 3, you get that one. 5, you get that one. 7, you get that one. It keeps going. Where actually this stuff comes in handy, why electrical engineers look at this is in communication. The signals that we're getting, the interference that we're getting, we can eliminate that if we know what these functions are. You'll get to that later in life there. You know, in like 3rd, 4th year engineering. There's actually a class, it should be, I don't know, when I was in college, we had a class called Advanced Math class. And that's where you cover a lot of that stuff here. There's math in it. But I want people to see it at least once or twice here, you know. But that's what Fourier analysis.
I'm pretty sure we use that a lot in fields and waves, don't we?
Yep.
Yeah, so we'd rather
That-
learn it here than there.
Well, that's just breaking the function to the summation. You know, at least he's seeing it. But the application, you're not going to see it here. You know, we don't have time. Today is the last class. And
We'll come right through the summer.
you can come back
8 a.m. every morning.
in the summer. So let's try maybe another one. Got to make sure I don't lose your test here.
Yeah, but see, Z, if we learn it from a physicist, then we'd never understand it.
Well, Topier is not that bad. Well, I shouldn't say his name, so on TV now. It's like when Burns one time was skipping a class. He goes, "Listen, I'm going to be skipping, but don't tell anyone." He forgot he was recording that. You know, Burnsy, ask him about that. They're like, "Oops." Let's take another one quickly, where an might not be 0 here. I don't know. I have no idea what's going to be here for this. Honestly, don't know what the answer is. Sawtooth. Do we have that in the lab on the scope? You get a sawtooth signal. It goes like this. Then it comes down.
Oh, that.
You get a function that looks like this, right?
Probably not underneath. No, you gotta have messages.
And that's enough with pictures. I'm not going to do 10,000 of them. And we do the same thing from this end here. So we have a periodic function again. And I'll just leave it without numbers. So I'll say, you know what? Let's call this 0. This is T0. That's the first period. This is T1, T2, T3. I don't know, we're going to negative T0, negative T1. And let's give it a height of A. Don't even use any numbers. Whatever height you want to use, A. Again, Fourier said, you can take this and replace this whole function with some constant plus the summation of n equals 1 to infinity of an sine, cosine. A is always the cosine, B is always the sine. Cosine n w0t plus bn, I'll put boxes around them, sine n w0t. And the first thing we have to get, actually, what is A0, what's AN, what's BN? First thing first, my period, T, is equal to what? T0 here? My frequency, it's 1 over T0. What's W? You can say 2 pi f. And if you look, by the way, I'm using this definition. I don't know if you can see it on the screen. That's what I'm looking at. Can you see that equation? That's the definition I'm using. Two pi f of 0. So 2 pi over t. That's what W is. So let's begin by finding A0. A0 equals the integral over a full period from 0 to T0 of f of t. What is the value of this function? This function. What's the expression for it? Isn't that a straight line? Right here? What is the slope of that straight line? Isn't it the rise over the run? What's the rise? What's the run? T0. T has a y-intercept of 0. dt. Oh, I forgot the 1 over t in the front. I'll just leave it 1 over T0. So that's equal to what? 1 over t0. And let's integrate that. Well, I can pull the a over t0 outside. The integral from 0 to t0 of t dt. So I will have a over what? t0 squared. What's the integral of t? T squared over 2 from 0 to t0.
It's just gonna be a over 2.
Correct. So when you plug in t0, that's t0 squared over 2 minus, when it's 0, that's going to be 0. So you end up with a over 2. That's what a0 should be. Now we're going to find, the math is going to be fun. I have to pull the graphing calculator out, the fancy one. Get your calculator ready there.
Oh, mine.
Come on, Eli. Otherwise, we have to use integration by parts. Coming up.
We'll be fine. No problem.
Did I give you the calculator to use?
Yeah.
Oh, right here.
What do you need here?
Well, when I get to AN. Practice, make sure it's working before you get to your test.
Yeah, I'll see what you deleted on here.
No, we put it back in.
Oh, because it didn't
Yep.
turn on yesterday until like 1:30.
Every time I does that, I go through, it's like all of my settings.
Let's try AN. AN is what? 2 over t, the definition. The integral from 0 to t, f of t, cosine, and w0 t dt. So let's plug in the values here. AN, 2 over t. What was my t? t0. The integral from 0 to t0. We said the value of the function is a over t0. Oh, I use capital T for t0. T times cosine, and what was my w0? 2 pi over t0 t dt. And now we're just going to have fun with the integration. Leave that page here. I can factor the a out. 2a t0 squared, the integral from 0 to t0, t cosine 2n pi over t0 t dt. I don't know if your calculator is going to be able to do that.
You can solve this one with
The derivative, the function, their derivative?
yeah.
Yep.
No.
You got 2 and the derivative of that, then the derivative of this?
That's it.
Yep. Well, it's integration by parts, but the shortcut to that, you write usually u times dv minus integral v du, right?
No.
Or you do, yeah, that's the method. But what you do, you write t here and the derivative of that, which is what? 1, right? Then the derivative of that is 0. Is that what you're thinking? Then you put the function here. Well, that's really integration by parts with a shortcut.
Yeah, I didn't learn that
Yep.
this year.
Yeah. What's the shortcut?
This semester. Like Burns never showed us.
What, this one?
Yeah.
Yep.
Showed it to us in Calc too.
So what you do, you take the derivative of this, right? So the derivative of that will be The integral of that, yeah. The integral of this, I gotta flip them now. This will be 1 over that, that'll be t0 over 2n pi. Derivative, the integral of cosine. Who has derivative of cosine? Is it the sine?
Yep.
Then you do another integral of this. You end up with what? T0 squared over, what's that? 4n squared pi squared, I think, right?
Yep.
And who has derivative of sine? Negative cosine, be a negative here. Cosine 2n pi t0 t. Then, is it this one times this? Then minus, right? This one times that? Is that how you did them? This one times this. I never do them the shortcut, by the way. I always derive them.
Plus, minus, you do check it.
So this is, yeah, this is the plus. That's what I'm saying. This times this. And this is the minus. This times that. Then the next one is 0. It doesn't matter. So when you integrate this, you end up with, there's the 2a in the front. Can't forget that. So an equals 2a over t0 squared times this times this, t times t0 over 2n pi n whatever. Minus, well, minus and minus will be a plus. This will be t0 squared over 4n squared pi squared cosine 2n pi over t0 t, and it's going from 0 to t0. We can clean it a little bit there. T0 cancels one of these, right? 2 cancels this 2. If I do the first one, so the 2's are gone. So it's A. Keep your eyes open, because I might make a mistake. There's a good chance. There's a T still there, right? A times T. The 2 is gone. One of the T0s is gone. It's left 2, 0, and pi in the bottom. Plus, this cancels this. 2 cancels one of these. I have A over 2 n squared pi squared cosine 2n pi t0 t, as t goes from 0 to t0. If I did the math correctly, we plug in the limit, we put in t0 for each one. So I will have what? t0 here. The t0 cancels the t0. I will have a over n pi sine t0 cancel t0 2n pi plus, now if I did my math correctly, I should have what? N over 2n squared pi squared cosine 2n pi t0 cancel t0. That's the upper limit. Minus, let's do the lower limit. When t is 0, when t is 0, this is gone. Minus, when t is 0, what's cosine of 0? Isn't cosine of 0 1? So you end up with a over 2n squared pi squared.
Shouldn't that be the plus between 0 and
Oh yeah, plus here. Yep. This one is 0 plus the answer to this, which is that one. So let's plug in the limit. What's sine 2n, 2 pi? That's a 0. What's cosine 2 pi, 4 pi, 6 pi? That's a 1. So I'm going to have a over 2n squared pi squared minus a over 2n squared pi squared. Guess what? an equals to what? 0 again in this example. It's not always 0. I just happen to pick two lousy problems. an for both happens to be 0. So all this work just to get an.
If you end up getting your wave in terms of sine and cosine, could you then use phasor to solve the circuit?
Well, you use superposition, yeah. So basically, the technique you're going to use is you have every source, you treat them as separate source, and have infinite source, you use superposition for each one, see what the result will be.
Isn't
Yes.
this basically like the summation thing, superposition
Yep.
itself?
Yep. So that's an. Now we need to find bn, then we're done. Where's the other page I have? Right here. My notes are nice and clean. Let's keep them that way. Maybe I'll put this video up there. bn. It's 2 over t, the integral over a full period, which is t0, really the period here. I'll just put t0 directly. F of t sine n w0 t dt. We said that's a over t0 times t, that's the function of sine, and when I plugged in the value for w0, where'd you go, w0? Okay. Right there, 2 pi over t0. When you plug it in, that's n 2 pi over t0 t dt. And now I can do the same thing I did before. So that will be 2a over t0 squared to n pi over t0 t dt. Again, integration by parts, I'll use the shortcut for that. If I do the shortcut, here we go. This is t. Derivative of that is 1. Derivative of 1 is 0. Let's look at that one. Sine 2n pi over t0 t. The integral of that, so it should be a negative, right? You have a sign, it should be a negative. And it's the negative will be 1 over this, so it's negative t0 over 2n pi cosine 2n pi t0 times t. Integrate this again. Where's derivative of cosine is the sine. So I end up with negative t0 over, well, that be squared. That'll be 4n squared pi squared sine 2n pi if anyone's watching this and having a hard time with it, like, how'd you come up with this? Just a quick way to look at it. If you take the sign here, you go two pi n over t0 t. We know The integral of sine is cosine, but where people struggle is this. Okay, let me put cosine. If I ask you, what's the derivative cosine of that? What's the derivative cosine this? Isn't that the sine of 2n pi over t0 times t times the derivative of this? And what's the derivative of this? 2n pi over t0. Well, you don't have that here. So what do you want to do then? You say, well, I need to have that here. So you can actually take this problem that you see here, you go, I want to find the integral of this. So what I'm going to do, add that piece to the front, and to make sure that I don't actually ruin the problem, I'm going to multiply it by the reciprocal. This way I'm not changing the problem. That's actually what I'm doing in my head. Everyone see that? I'm doing this in my head. I'm going, I need to do this here to get, so that will be the derivative cosine. That will give me the cosine here. The integral of that will be the cosine of this. And there's the constant. And that's why I have, there's cosine's negative sign. Yep, I need a minus. Derivative of cosine is negative sign. So that's how I came up with that value there, in case you're wondering. Sometimes I go through them quickly there. And again, we go this one times this, and that's the plus, minus this one times that. Here we go. Bn equals to, I have a constant on the front, 2a over t0. And let me find the answer to this. It's going to be this times that. So that's negative t0 times t over 2n pi cosine 2n pi over t0t minus this times that. Well, that'll make it a plus now. Minus a minus is a plus. 1 times that, that'll be t0 squared over 4n squared pi squared sine 2n pi over t0 times t. And you go from where? From 0 to t0.
The 2a over t0 is to be squared. The t0 squared.
Yes. 2a over t0 squared. Thank you. That's a square here. Right here. So now if I can finish this, I got the expression. Okay, good luck to all of us. When, you know what, let's plug in the limits. T0, when this is T0, that cancels this 2n pi. So I'll have the upper limit. Here we go. 2a over T0 squared negative T0 squared, because I'm plugging T0 for that, over 2n pi cosine 2n pi plus, when this is T0, sine 2n pi. Here's good news. What's sine 2 pi, 4 pi, 6 pi, 9 pi?
0.
0. I'm not done with this. I just got excited about this part. What's the cosine of 2n pi? 1. 1. It's always 1. So subtract from the lower limit. We'll come back and finish it. Minus the lower limit when it's 0. I'll have 2a over t0 squared. 0 times anything is what? 0 plus t0 squared over 4n squared pi squared. And what is sine of 0? That's a 0. That's gone. So what's left? Let's cancel these guys here. What do we have? Is it negative a over what? N pi? That's it.
That's it.
That's it. So what's f of t equal to? It's, I forgot what a0, was it a over 2? I think it was a over 2. Plus the summation, n equals 1 to infinity. Only bn, an is gone. Negative a over n pi, that's what bn is, sine 2n pi over t0 times t. And that's the expression for f of t. You can take any periodic function and rewrite that in terms of sine, cosine, some constant.
So the basic functions like triangle, sawtooth, and square wave, will they usually come out to nice functions like this, even if the math is ugly?
Most of these actually, I don't know if they'll end up that nice. This actually was really nice the way it ended up. I can't guarantee actually they'll be that nice. You know?
Because if they all came out this nice, it'd be great.
Probably not. And you can tell, even if you have fancy graphing calculator, it's really not that easy to integrate that, even on your, because there's so many unknowns in it. Couldn't do it? Yeah. So you have to do it by hand.